so this is from lesson 10.8. Factoring using the distributive property. All right, so the first problem I'm going to work for you is number 22. And it is negative 3w to the fourth plus 21w cubed. Okay, so for this problem, what we're going to do is we're going to see if we can factor anything out of both of the terms before we start factoring the whole expression. Notice there's a 3 here and there's a 21 here. 21 has 3 as one of his factors. He's 3 times 7. So we can factor out, I'm going to factor out negative 3 actually, because I don't want to have a negative in my first term. We're going to factor out a negative 3 using the distributive property. We're going to sort of undistribute it from these two guys. We also can factor out a variable. We have w to the fourth here and w to the third here. And if we remember that w to the fourth is actually w to the third times w, we could factor w to the third out of both of them. So now what's left? Well, if we factor out negative 3w to the third out of this guy, the only thing left is a single w. And if we factor negative 3w to the third out of this guy, well, the only thing left here is going to be negative 7, because 21 divided by negative 3 is negative 7, and w to the third divided by w to the third is just a 1, so we don't have to worry about him because it's negative 7 times 1. Don't have to write the 1. So we just have w minus 7. And this is as simplified as something can get. W minus 7, boom. This is our answer. Okay, now I'm going to do one that's a little bit more complicated. Let's see, we're going to do number 24 now. And it is 5x squared. Oh no, 5x to the third. X to the third plus 30x squared plus 40x. So first thing we should notice, there's 3 terms here, but each of the terms has an x. So that tells us that at least x can be factored out of all 3 terms. So I'm going to go ahead and put an x here. Parentheses for whatever's left, but at least we're going to factor out an x. Now let's look at a number that we might be able to factor out. And actually I'm going to put the x beside the parentheses because we want to put the number on the left side. 5, 30, 40. These two guys have 10 in common as well as 5, but this guy only has a 5, so we cannot take out a 10. Even though we could take a 10 out of both of these guys, we can't take a 10 out of him. The highest number we can take out, or the greatest common factor of these 3 numbers, is 5. So we're going to put a 5 here, and then we're going to say 5x cubed divided by 5x will be 5 and 5 will make a 1, and x cubed divided by x will be x squared. We don't have to put the 1. We can if we want to. We don't have to put it. 30x squared, we'll do 30 divided by 5, that is 6, and x squared divided by x is just x. And then we're going to come to the last term, 40 divided by 5, and then x divided by x, and that's just going to be 8, because the x's will completely cancel out. So let's make sure it works. 5x squared times x squared would be 5x to the third. 5x times 6x would be 30x squared, and 5x times 8 would be 40x. So it makes the original problem. What?
I didn't get this before. I understand it now.
Good. Very good. All right, so we now have it simplified, but it's not factored all the way. We've just used the distributive property to make this less complicated. We still have to factor this long guy in the parentheses. What is the name of a 3-term polynomial? Trinomial. Very good. So we still have to factor the trinomial. All right, so I'm just going to write him right here for now, but we can't forget that overall he's multiplied by 5x. But we're just going to look at this piece for a moment. All right, this is a lot easier to factor because we just need to find 2 numbers, and we don't have to worry about the factors of him because they're just 1 and 1. We need to find 2 numbers that multiply to make 8 and that add to make 6. And that is super, super easy because it's just 4 and 2, right? 4 times 2 will make 8, and then 4 plus 2 will make 6. And then we pull back down the 5x because we don't want to lose him. And this is how we simplify this original problem. Okay, I'm going to do one more from this lesson because they throw a new concept in there as well. It's not exactly new, it's just they've not had you do this with this kind of problem before. So they give you a problem that looks like this. So number 30 is a little weird. Number 30 is x cubed minus 3x squared plus x minus 3. If you just were to look at this, you might not have any idea how to factor this. Isn't it kind of strange? Yeah.
I know. I mean, I'm pretty sure I know how to do it.
Yeah?
It's wait. You still use the distributive property, right?
You could, except this is a 4-term property and there's nothing that all 4 of these terms have in common. Right? Because these 3 have an x, but this one doesn't. And these 2 have a 3, but these 2 don't. But notice something really, really weird. This is x minus 3. Is this also x minus 3 just multiplied by something?
Yeah.
Yes. So let's break it here. Yeah, I think you're on the right track, Arnie. We're going to break it here. We're going to factor out x squared from just right here. And we're going to get x, right? Because x cubed divided by x squared will be x. Yep, minus 3. And now notice what we have. We have an x minus 3 and we have an x minus 3. We can actually factor this because all we have to remember is that this technically, so we're going to say plus 1 times x minus 3, right? We can write that if we want to. It won't hurt anything. 1 times x minus 3. Now we can use the distributive property sort of backwards to say, okay, so x needs to be multiplied by this, and 1 needs to be multiplied by this, which is the same thing. So technically, we could add x squared, and sorry, I meant to say x before, x squared and 1 together, and multiply them both by x minus 3. Couldn't we? It's kind of a weird way to do it. It's called factoring by grouping.
Oh yeah.
Mm-hmm.
Like that's.
So it's new in the way you're applying it here, but it's not like a new property. It's just the distributive property used in a different way.
Okay. So it would be like you're trying to get it so that you can factor it by like FOIL.
Yes. Yeah. This would work with FOIL. We could still FOIL it back to the original problem.
So you're like unfoiling it? Is that how you say it?
Yes. Yeah. That's what I call it, is unfoiling it. That's not the technical term, but technical term is factoring, but unfoiling helps us remember what our goal is.
But isn't factoring like taking it from like what it
is factoring.
Oh, so the other way around is not factoring?
This is foiling.
Okay. So factoring is taking it from the
This is called the expanded version.
Yeah, the expanded version. It's not an equation, it's just like
an expression.
Expression.
Yeah.
So the difference between an expression and an equation is that expression doesn't have like the equal sign.
Exactly. An equation, equate equals. Equations have equal signs. Expressions do not. They're just a collection of terms. All right. So this is how you're going to factor one of these guys by grouping.
Okay.